Using the wrong oil grade is one of the fastest ways to destroy your engine. Here are 7 warning signs it's happening right now, and the last one destroys more engines than all the others combined. Sign number 7. The cold morning rattle. Ever start your car on a cold morning and hear that ticking or rattling sound? Most people ignore it, thinking it goes away once it warms up, so it's fine. But that sound is your engine screaming for help. Here's what's actually happening. When you use oil that's too thick for your engine, like pouring 10W40 into a car designed for 0W20, the oil moves like cold honey. It's sluggish. And in those first few seconds after startup, critical parts like your camshaft, filters, and timing chain aren't getting oil fast enough. Let me paint the picture. You turn the key, the starter cranks, the engine fires up, but for the first 3 to 5 seconds, oil is still crawling through the passages. Your valve train is running almost dry, metal is rubbing on metal, and every single cold start chips away at components that were supposed to last the life of the engine. Think about your timing chain tensioners. They need oil pressure immediately to keep the chain tight and stable. When that oil takes too long to arrive, the chain slaps around, hammers the guides, and slowly wears down plastic components that can't be replaced easily. I've seen timing chain guides crack in half on engines with less than 70,000 miles, all because someone used 10W30 instead of 0W20. Sure, the noise stops once the engine warms up and the oil finally flows, but the damage, that's already done, and it happens every single time you start the car. Once a day, that's 365 cold starts a year. Do that for 3 years, and you've got over 1,000 micro-damage events stacking up. The fix is simple. Use the grade your manual recommends, especially for cold weather. Those winter numbers like 0W exist for a reason. They flow instantly, even when it's freezing outside. Don't let old-school thinking about thick oil for protection fool you. Modern engines are built different, and they need oil that moves fast. But if you think a little rattle is no big deal, the next sign will make you think twice. Sign number 6. That flickering oil light at idle. Picture this. You're sitting at a red light and the oil pressure light flickers. Just for a second, then it goes away. You tell yourself it's probably nothing and keep driving. But here's what that flicker really means. Your oil pressure is dropping too low to protect your engine. And if you're using oil that's too thin for a worn or high mileage engine, you're asking for trouble. Oil pressure is what keeps your crankshaft floating on a thin film of oil inside the bearings. It's like a microscopic cushion between metal surfaces. When pressure drops, that cushion disappears. Metal touches metal, heat builds, and your bearings start to die. This happens a lot when people switch to thinner oil, thinking it'll improve fuel economy. They go from 5W30 down to 0W20, and suddenly the engine can't maintain proper pressure at idle. Especially when it's hot outside or after a long drive, the oil is just too thin to fill the worn clearances that naturally develop over time. Here's the thing about bearings. They're precision parts with tolerances measured in thousandths of an inch. As an engine ages, those clearances open up slightly. It's normal wear. But if you switch to oil that's thinner than the engine was designed for, you're not accounting for that wear. The oil film can't support the load anymore. A flickering oil light is never normal. It's your engine telling you something's wrong with the oil you chose. Maybe you went too thin. Maybe your engine has 150,000 miles and needs a slightly thicker grade now. Either way, ignoring it puts you one step closer to spinning a bearing, which means a full engine rebuild. And we're talking $2,500 to $6,000, depending on the engine and how far the damage has spread. I've seen guys drive for months with a flickering light, thinking it only does it when it's hot, so I'll deal with it later. Then one day, they're on the highway, the light stays on, and the engine seizes. Game over. All because they didn't respect what that little light was trying to tell them. And once that pressure problem starts, it often leads straight to the next disaster. Sign number 5. Blue smoke and burning oil. Here's a sign you can actually see. Blue smoke coming out of your exhaust. It happens during acceleration or when you let off the gas, and it means your engine is burning oil. Now, using the wrong viscosity causes this in 2 ways. If your oil is too thin, it slips past the piston rings and the valve seals like water through a sieve. If it's too thick, It doesn't drain back down to the oil pan fast enough and sits up in the cylinder head, where it gets sucked into the combustion chamber. Either way, you're burning oil that should be lubricating your engine. And here's the kicker, you're also losing oil level fast. Some engines can burn through a quart every 500 miles when the wrong grade is used. That's not normal. That's a sign something's wrong. What's worse is that burned oil leaves behind carbon deposits on your pistons and valves. Those deposits create hot spots that can cause engine knock and detonation, especially dangerous if you've got a turbo. Direct injection engines are particularly vulnerable because they don't have fuel washing over the intake valves. Once carbon builds up, it's there to stay unless you pay for a walnut blasting service. And while all that's happening, your catalytic converter is getting clogged with ash from the burned oil. Catalytic converters aren't designed to handle oil, they're meant for exhaust gases. When oil burns and goes through the cat, it leaves behind metallic ash that coats the honeycomb structure inside. Eventually, the converter chokes itself and stops working. Replacement cost? $1,200 to $3,000 depending on the vehicle. Many drivers think oil consumption is just how the car is, especially on older Honda Accords, Toyota Camrys, or Subarus. But the truth is, it's often a symptom of using oil that doesn't match what the engine was designed for. Switch to the right grade, and you'd be surprised how much that consumption drops. And speaking of design, the next sign is where things get really expensive. If you're finding this helpful, hit that subscribe button and turn on notifications. We share tips like this every week to help you avoid $1,000 mistakes that dealers won't tell you about. Now let's get to the serious stuff. Sign number 4. The dreaded engine knock? This one's serious. If you hear a deep knocking sound when you accelerate, especially in a high-performance or high-mileage engine, you're likely dealing with rod bearing wear. And once that starts, you're on borrowed time. Here's why it happens. Rod bearings need thick enough oil to keep the crankshaft journal floating without contact. But when you use oil that's too thin, it shears apart under heat and pressure, especially at high RPMs. The protective film collapses and metal starts grinding on metal. That knocking sound, that's the sound of your bearings being destroyed. And once bearing material breaks off, those metal particles circulate through your entire engine, clogging oil passages, damaging the oil pump, and contaminating everything they touch. Think of it like sandpaper grinding through your engine. Those particles are abrasive. They wear down everything they pass through. I've seen this happen a lot with performance cars. Someone switches to a lighter oil because they read online it'll give them better fuel economy or a few extra horsepower. Then 6 months later, they're staring at a $5,000 engine rebuild because the rod bearings are toast. BMW M Series engines are notorious for this. The S54, S65, and S85 engines need specific viscosity to keep rod bearings happy. Use oil that's too thin, and you're asking for trouble. Same with Subaru EJ25 turbo engines. They run hot, they run hard, and they need oil that can handle the punishment. Switch to something too thin, and the bearings give up fast. Honda Type R engines, Toyota GR Corollas, any turbocharged 4-cylinder pushed hard, they all have one thing in common: tight tolerances and high thermal loads. The oil grade isn't a suggestion, it's a requirement calculated by engineers who know exactly how much stress those bearings are under. Knocking isn't something you can ignore and hope goes away. It gets worse, it gets louder, and then one day, you're driving down the highway and you hear a loud bang. The engine dies. That's a thrown rod. The connecting rod breaks, punches a hole through the block, and your engine is scrap metal. No fixing that. You're looking at a used engine, and bearing replacement alone runs $2,000 to $3,000 if you catch it early. Wait too long, and you're into full rebuild territory at $5,000 to $6,000. But before the crank completely fails, another system usually starts screaming first. Sign number 3: overheating and oil breakdown. Oil doesn't just lubricate, it also cools. And when you're running oil that's too thin for the conditions you're driving in, it breaks down under heat. Let's say you're towing a trailer in the summer or driving long highway stretches through the desert with 0 W20 oil in the engine. That oil wasn't designed for sustained high heat. It thins out even more, loses its protective properties, and starts to chemically change. The additives that prevent foaming, oxidation, and wear start breaking down. You're left with oil that's barely better than water. Overheated oil loses its additives, starts to foam, and becomes acidic. That acidity attacks aluminum engine parts, gaskets, and seals. You'll start seeing burnt varnish inside the valve cover, that brown, sticky residue that looks like someone cooked caramel in your engine. That's oxidized oil that got so hot it literally baked onto metal surfaces. And if you've got a turbocharger, this is a death sentence. Turbos spin at 200,000 RPM and rely on stable oil viscosity to prevent metal-to-metal contact. When oil overheats and thins out, it carbonizes inside the turbo housing, forming hard black crystals that destroy the bearings. Once those crystals form, the turbo shaft starts wobbling, the compressor wheel scrapes the housing, and eventually the whole thing locks up or flies apart. Replacing a turbo isn't cheap. OEM turbos run $1,500 to $4,000 for parts alone, and with labor you're looking at $2,000 to $3,000 total on average, all because the oil couldn't handle the heat. I've seen this on Ford EcoBoost engines, Chevy 2.7-liter turbos, and Ram Eco diesel trucks. People tow heavy loads in Arizona or Texas summer heat with zero W20 oil, and the turbos fail at 80,000 miles. Meanwhile, someone running the same engine in Montana with proper oil for the conditions will get 200,000 miles without issues. Climate matters. Driving style matters. If you're doing heavy-duty work, you need oil that can handle it, not the lightest grade on the shelf just because it says fuel economy on the bottle. But sometimes the opposite mistake causes just as much damage. Sign number 2. Sludge buildup and oil starvation. Here's a myth that won't die. Thicker oil means more protection. Sounds logical, right? But in modern engines, it's flat out wrong. Today's engines have incredibly tight tolerances and tiny oil passages. They're designed to run on thin, fast-flowing oil like 0W20 or even 0W16. When you pour thick oil on, say, 10W40 into an engine built for thin oil, it can't reach where it needs to go. First thing that fails? Variable valve timing actuators. You'll hear chain rattle, rough idling, and hard starts. The actuators aren't getting oil fast enough to respond to the computer's commands. So timing goes off, performance drops, and fuel economy tanks. Then the real trouble begins. Sludge. Thick oil sits on hot metal surfaces and bakes. Over time, it turns into a tar-like substance that clogs oil passages, coats components, and restricts flow. The oil pickup screen at the bottom of your oil pan gets blocked, the pump starts struggling, and pressure drops. I've pulled valve covers off engines that were running 10W40 in a 0W20 engine, and the inside looked like someone poured molasses and let it cook. The cam lobes were coated in black sludge. The oil passages were clogged. The VVT screens were completely blocked, and this was on an engine with only 60,000 miles. Eventually, the engine starves for oil, even though the dipstick says it's full. And when that happens, everything inside starts wearing out fast. Bearings go first, then cam lobes, then piston rings. The whole engine starts eating itself from lack of lubrication, even though there's 5 quarts sitting in the pan. This is especially deadly for hybrid engines and direct injection models, which depend on precise oil flow to keep timing systems and fuel injectors working. Toyota hybrids, Honda hybrids, Ford hybrids, they all use 0W20 for a reason. The engine shuts off and restarts constantly. It needs oil that flows instantly every single time. Use thick oil, and those restarts become wear events. Modern engines are built different. The clearances are tighter, the oil passages are smaller, the technology is more advanced. Respect that or pay the price. And the price is usually a new engine. But the most misunderstood damage happens in a system most drivers never even think about. Sign number 1. Timing system and hydraulic lifter failure. Variable valve timing and hydraulic lifters. These aren't just fancy features. They're the brain of your engine's breathing system. And they live or die based on one thing: oil viscosity. Here's how it works. These systems aren't controlled by springs or cables. They're controlled by oil pressure. When the computer tells the engine to adjust valve timing, it does it by routing oil through tiny passages to actuators called VVT phasers. Those phasers rotate the camshaft slightly to change when the valves open and close. It's how your engine makes power at high RPM and saves fuel at low RPM. Use oil that's too thin, the phasers overshoot or can't hold position, the computer throws camshaft position error codes P0011, P0021, P0016. Your engine stumbles, misfires, and idles rough. The check engine light comes on, and if you ignore it long enough, the phasers wear out completely and need replacement. That's $800 to $1,500 per side, plus labor. Use oil that's too thick. The phasers can't fill fast enough, especially on cold starts. They lag behind, lifters start ticking, and the camshaft wears unevenly. Over time, the entire valve train geometry collapses. Cam lobes wear flat, lifters collapse, and eventually you're looking at a cylinder head rebuild. I've seen this on nearly every modern engine: GM's 2.0-liter turbo, Ford's 3.5-liter EcoBoost, Honda's 1.5-liter turbo, Toyota's 2.5-liter four-cylinder, Nissan's VQ V6. They all use VVT, and they all fail when you use the wrong oil. Hydraulic lifters are just as sensitive. They rely on oil pressure to maintain proper valve lash. Too thin, and they pump up too much. Too thick, and they can't pump up at all. Either way, you get valve train noise and premature wear. This is why engineers spend years testing and specifying exact oil grades for every engine. It's not about marketing. It's not about making money for the dealership. It's about flow rate, pressure stability, film strength, and thermal behavior, all matched precisely to the engine's internal clearances. Every modern engine is designed around a specific oil viscosity. The bearing clearances are sized for it. The oil pump is calibrated for it. The VVT system depends on it. Change that viscosity, and you throw off the entire balance. And that's when failures start happening. Ignore those specs, and you're not just shortening your engine's life. You're ripping it apart from the inside, one start at a time. And by the time you notice something's wrong, the damage is already done. And there you have it. 7 warning signs that you're using the wrong oil grade, and how each one is destroying your engine. Which of these signs have you noticed in your own car? Drop a comment below and let us know. Your experience might help someone else avoid an expensive mistake. And if this video just saved you a few $1,000s, click here for the next video right now before another hidden problem costs you more. Thanks for watching, and we'll see you in the next one.